Okay, guys, my name is Desmond, and I welcome you to my lesson for today. Ladies and gentlemen, how are you guys doing? Is there someone who has attended today's lesson?
Hi, sir. How are you?
Yes.
Yes, sir.
Okay,
Yes, sir.
100%. So I notice there's someone who has attended today's lesson. So good people, in today's lesson, I just want us to refresh our minds because throughout the week we've been doing some problems related to analytical geometry. So in today's lesson, I just want us to quickly have a look at solve for X type of problems, because one thing for sure, you should expect this type of questions in your June exam question paper. One thing for sure, it will be there. Somewhere in your question paper, you might need to simplify. And again, you might have problems related to surds, of which I just need to refresh your minds, guys, while I'm still thinking about what will be the next chapter. So for today's lesson, I'm going to give an opportunity to select some questions that you think are a little bit tricky so that I can guide you in terms of how to approach those type of problems. So just make sure that you are able to access that image that I sent in the group so that in the meantime, while the lesson is busy, you can be checking the types of problems that you always find difficult. So guys, I hope everyone is good and all is in order. But before we do anything, I just want to have a quick lesson there
Forget about the
say
code, sir.
someone is making a comment. I see it's Anita. Anita, did you say something?
Just reminding you about the code.
Oh, yes. Yes. Thanks very much, Anita. So, let's see. After this mini lesson, let's generate a code, guys. So, what I wanted to say, good people, is that in mathematics, we do mostly two things. 2 minutes. Let me just do this. Guys, sorry about that. I just had to quickly attend something, so I had my mic muted. But anyway, so what I wanted to say, guys, is that in mathematics we do these two main things. The first thing, not necessarily the first thing, but it's what I'm going to explain first. We normally solve in mathematics. It's either you solve or you simplify. So I won't be going deep into explaining both of these, but I'm just going to give you the background. So a full lesson on this will be included in my winter school, but just make sure that for now you are aware of what I'm explaining now. So good people, when you solve for the unknown. So when you solve, you can write this as part of your notes to say, when you solve for the unknown. It's unfortunate I did not prepare for this lesson or for this part of the lesson that I'm doing. I just thought of doing it as part of refreshing your minds. And again, for some of you guys will be seeing me presenting this type of information for the first time. So when we solve, guys, you solve for the unknown. What is the unknown? The unknown can be represented by any letter from A up to Z. So how do you notice that in this case, I have to solve. That's if you are given an equation. Guys, write this as part of your notes. That's if you are given an equation. How do you see an equation? An equation has got an equal sign. So that equal sign, it means an equation. What does an equation mean? It means the left side must be equals to the right side. So that's normally what we do when we solve a mathematical problem. We solve for the unknown, we must be given an equation, and again, we have got types of equations. So we can have what we call a linear equation. So a linear equation, guys, is those type of equations where, for example, let's say it's x plus 4 is equals to 2. So can you see in this case, guys, what is the unknown? The unknown is a letter. What is the letter for this problem? Is letter x. Then what does it mean? It means in the end, we must say x is equals to whatever, of which in this case, x is equals to -2. So we say this is a linear equation because the exponent on the letter is that invisible 1. So another type of an equation that we might be given is a quadratic equation. A quadratic equation. So we can also be given a type of equation, an equation which is a quadratic. This is how you see a quadratic. The moment you have a letter and a square, then you know you have a quadratic. Let's say maybe plus 4, and this is equals to 0. So when we are dealing with quadratic equations, what we normally do is to find the factors. So for now, under solving, let's just leave it there. Then under simplification. So when we simplify, guys, it's more like we want to rewrite either a long or a complicated expression into its smallest part. So that means, guys, when we solve, we must be given an equation. But when we simplify, we must be given an expression. So that means simplify expression. Let's see expression. So you can just write that as part of your notes. Then when we solve, it means we are given an equation. So under simplification, it's more like you want to write something from complex to simple. I'll give you an example, guys. Let's say maybe, for example, you are given 2x minus 1 plus 7x minus 4, let's say, plus p. So can you see? This is what we call an expression, ladies and gentlemen. So how do you see if the problem is an expression? It's because there is no equal sign. So if you are given a problem and that problem does not have an equal sign, then it means it's an expression. What does it mean if it's an expression? It means you simplify. What does it mean if you simplify? You write from complex to simple. For example, that type of a problem there, it is an expression because there is no equal sign. So what does it mean? It means you have to rewrite that long or complicated problem into its smallest form. So that means every time when you simplify, the next step, the second step, the second step, whatever the steps you have, everything is the same. It's just that you are rewriting it in its simplest form. For example, there you can see you have 2 bananas, you have 7 bananas, then that means you have 8, 9 bananas, then you have -1, -4 is -5 plus p. Then it's done. You cannot further simplify that. So guys, I won't remove all of this. In today's lesson, I want to be applying all of this to solve the problems that I sent in the group. So guys, let's now derive a code. So Anita, what should be the code for today? Remember, from 0 to
Yeah.
10.
Any number, right? A letter or a number?
No, just a number. Let's say just a number.
Okay, let's just make it 7 then.
Wait, from 0 to, let's make it 7. So it's from 0 to 10. So guys, this is the code. Just make sure that you write that code. So let's see. Is there someone who wants to suggest which problem we could start with? Remember, guys, just mention your name, and then from there, based on those who mentioned their name, I'll just choose one. Then after, whoever who's chosen, just indicate the province that you are in, and then tell me which problem you suggest that we start with.
Wait, from the question paper.
Remember, guys, in the group, I'm not sure if it's myself or my admin who sent some maths problems in the group. Did you not find it? I think if you can click on back and check in the group, yes, I'm actually the one who sent it. Are you not seeing that, guys?
We can see.
I've seen it.
You're not able to see.
We have seen it, sir.
Let me check something. So the reason why I suggest that we choose is just in case if we are not able to do everything, but we cover the most complicated or difficult ones. So in case if you confirm that you are able to see, then is there someone who wants to mention their name to be included in the draw?
Yeah, sir.
So what do you mean?
Okay, so now that Shreyas has mentioned his name, so I'm going to recognize Shreyas. What Shreyas is going to do is to mention the province in which he is. Then from there, from that image, he's going to choose a problem that seems a bit difficult for him. Then I'm going to explain how to approach that type of a problem. So for the next person, you just have to make sure that you access that image that I send in the group. You look for that problem that you feel like this one is a bit intimidating. Then I'm going to explain to everyone, yourself included, to explain how you approach those type of problems. The reason to that is because if we follow the list and you find that it takes a bit longer, or otherwise, let's say, because I thought this lesson was going to be quick, but in case if it gets longer and we are not able to cover everything, at least we would have covered those type of problems which you find difficult. So I just want to make sure that we firstly start with those that you choose, of which you feel like they are a bit difficult. So Shreyas, go for it.
I'd like to question 1.3.
Question 1.3. Hey, yeah, Shreyas. What a choice. Let's see. Question 1. He says 1.3. So let's see. 1.3 says discuss the nature of the roots of the equation 2 into x minus 3 close squared plus 2. So, Shreyas, there's something that I'm noticing with regards to that question, because I forgot to mention this is an application of what you should have started with. So it's more like, for you to fully answer this question, you must have gone through some mathematical problems, of which for you to answer this question, you must apply all of those. So what I'm trying to say with regards to this one, guys, is that let's focus on this in the end, because before you get to this one, you must have gone through those other questions. So let's spare this one towards the end. Shreyas, remind me on that one. 1.3. So let's just pay it aside for now. So it's more like you need a warm-up before we can get to that one. I didn't notice that I couldn't mention that point. So LB, did you understand the rules for today's game?
Yes, sir. But sir, the question that he asked is kind of easy.
LB, I couldn't get the whole. Did you say it's easy? The first one.
I'm saying the 1.3 that he asked, sir. It's easy.
Oh, you say okay. Then it's fine. I think for that one, I'll give it to you to just take us through. But in the meantime, let's put it as the last question. So remember, LB and everyone else, in this lesson, this is a master class where we've got our grade 10, 11, and 12. So I won't tell for which question is that one. The reason to that is because for some of you, if you know, some they just pull out a memo, and then they already know the answers, and again, instead of them calculating, they can see what the final answer is, and when I ask questions, they just give the final answer. So remember, LB, some questions may be easy to others, some may be difficult to others, but one thing for sure, someone like Shreyas, he's at an advanced level. That includes, I'm not sure of the other guys or who's attending, because Shreyas has been with me since early this year, but he's in grade 10. So he's also able to participate and understand some lessons for grade 11 and 12. I know Ferdinand is also in grade 10, but he started recently with my lesson. So he's still in the making. So guys, I think now let's try the next question. So it doesn't matter whether it's easy or difficult, but that one, LB, I'm going to put it aside. We'll do it in the end. I'll give you an opportunity to present that one. So
Sir.
someone to choose a question, guys.
Sir.
Do you want to?
Okay, can I choose?
Yes. You can choose.
Okay, it's LB speaking. Can you please do the simultaneous one, 1.2?
Simultaneous 1.2. Okay, so 1.2. Let's try a simultaneous, guys. So I'm just going to, let me just get that image. 1.2 is x plus 4 It's equals to 2y. What else are we having? We have, guys, just make sure that everything that I'm writing there is correct. Because in some lessons, guys, I copy things incorrectly and we go forever on a very simple problem. And this is allocated, is it 4 marks? No, it's 6. This one is allocated 6 marks. Okay, so guys, let's talk. When you are dealing with questions related to simultaneous equations, just make sure that you have 2 unknowns. First thing first, let me bring this. What type of a problem is this? Then this is what I look at. I look at it. It's either it's an equation or it's an expression. This is your starting point. It's either you're given an equation or an expression. So in this case, it seems like I'm given an equation. Why? Because I see that equal sign over there. Then it means this is an equation for that first equation there. So let's say this is equation number 1. And secondly, here comes a question. Is it a linear equation or a quadratic equation? Then this is a linear equation. Why? Because all the letters, they've got a power of invisible 1. And for that reason, this is an equation and it's a linear equation. So that means I must solve. What am I solving? I'm solving for the unknown. What unknown am I having for that equation number 1? I've got an unknown which is x and y. So that means in the end, I must say x is equals to whatever, y is equals to whatever. So I've discussed everything that I had to say with regards to the first equation. Let's go to the second one. So the second one, it's also an equation. Why? Because I see an equal sign over there. What type of an equation is this? This is a quadratic equation. Why? Because I see a letter has got a power of squared. So what does it mean? It means when I deal with this problem somewhere, I'll need to find factors. So let's consider this to be equation number 2. And most importantly, guys, when you are dealing with simultaneous equations, you must have 2 unknowns. That's when you know you are dealing with simultaneous equations for high school. When you get to varsity, you'll be solving for 3 unknowns. But let's not go that far. So what are the unknowns in this case? The unknown is letter x and letter y. So that means I'm actually solving for x and y. So even if they use a different letter, guys, it doesn't necessarily mean that always when you're solving for simultaneous equations, it will always be x and y. It could be any letter from A up to Z. So first thing first, you need to check for a simple equation where you've got an unknown with a coefficient being 1. For example, I'm simply saying between these 2 equations, which one seems a little simple? And again, from these 2 equations, which one can you use to derive equation number 3? So that means it seems like equation 1, it's easy to use to derive equation 3. So how do you derive equation 3? You want to make either x or y subject of the formula. So you want to make one unknown the subject of the formula. So you can easily make x the subject of the formula. So that means x is going to be equals to, you transpose everything to the other side of the equation and formally start with whatever that was there on the right side. So don't start with 4, but start with whatever that was there on the original equation. So that means you have 2y minus 4. So for you to forget to change that sign, then just know everything is wrong. So this is how you derive equation number 3. You say it's equation number 3 after you have successfully said x or the unknown is equals to everything right. So why did you have to derive equation number 3? Rivoni, the reason to that is because you want to substitute equation number 3 into that complicated equation. So that is your starting point. Very, very much important, ladies and gentlemen. So now let's substitute. So that means we are going to take equation number 3 and substitute or put it into equation number 2. So wherever we see x, we write the whole of this inside the brackets. Massively important, guys. So let's see. Y squared minus. Can you see, guys? There I've got x and there I've got y. So it's better to start with what is it? Y, to write y first, then you put all of that in brackets. But anyway, let's just write it as it is so that no one is confused. Remember, where we see x, we write that in brackets. So this is where we see x. That is why in brackets, we are going to have 2y minus 4 multiplied by that y plus 21 is equals to 0. So what I wanted to say, guys, is that remember, x, y, this thing is the same as y, x. Doesn't matter whether you write that letter or this letter first. So they had to write x first because alphabetically x comes first. So it's better if you had there, if it was just negative y into 2y minus 4, because it's easy to just say that times that and that times that. But even if you have it as negative 2y minus 4, then you have y on that side. It's still fine. You will just do that by that and that by that. So whichever way that suits you guys, you can write it. Don't worry that much about it. So let's continue. So that means we have y squared. Remember, guys, always you want to sort out the brackets. So that is why I'm writing this as it is. Then I'm going to say that times that. What are we having? So can you see the danger with this one of doing things in the backwards? Let's say this is doing things in the backwards. I'll show you the mistakes associated with that. You are going to say y squared, then you say minus, which is that minus. You will say that times that, and it gives you a 2y squared. Then you will say this times that, you say it gives you minus 4y, of which is wrong because you excluded that negative which was outside the bracket. So can you see the danger associated with doing things in reverse, guys? I'm glad I did not correct it from the beginning. So let me rewrite it correctly. So that means you must say y squared, then write this one this side as minus y into 2y minus 4 plus 21, it's equals to 0. Now you can do things nicely. So you'll say negative y times that, negative y times that. So consider that one of having y on this side as you walking in reverse, and with y being on this side as you walking forward. So it's better to do things as the manner in which you would walk. So that means we have y squared, that times that, it's minus 2y squared, that times that, it becomes positive, that times that, it's 4y plus 1, it's equals to 0. So here's the trick, guys. If that equation, it was not equated to 0, but let's say maybe it was equated to 8. So because you see that y squared, or because you see y squared there, the moment you see y squared, you know it's a quadratic. That means you want to move everything to the left and equate that particular quadratic equation to 0. Let's say maybe you had 2y squared minus 3 y, and this was equated to 9. What I mean by that, because you notice you have a letter which has got a power of squared, then move everything on this side to the right and equate it to 0. Just make sure that every time when you see a squared, to you it means move everything from the left to the right. Why? Because you need to write it in the standard form and factorize. So let's see. We can now work out the like term. So we have y squared minus 2y squared. So it's more like it's 1 minus 2, which is negative 1y squared, plus 4y plus 21, and this is equals to 0. So always, guys, when you have a quadratic equation, you do not want to have a negative number there. So you can just change the signs of everything. Someone in KZN might be saying we divide each term by -1. It doesn't really matter. When I change every sign, I'm saying this is negative y squared. Write it as positive y squared. This is positive 4y. Write it as minus 4y. This is positive 21. Write it as minus 21. This is equals to, this is positive 0. It's still the same as 0 when you want to say negative 0. So positive 0 and negative 0, both of these are the same as 0. So that is why I did not bother myself there to write negative 0, because I know it is 0. So just make sure, guys, that when you solve, you follow the correct mathematical procedure, of which I will have to prepare a lesson. I think it should be our starting lesson where we do maths basic rules, exponents, and everything, just so that as we proceed, you fully understand. Because for you to be able to solve mathematical problems, you must be able to solve for x, or otherwise solve for the unknown. Because if you don't, then you will still be able to interpret a function, but you won't be able to solve or calculate. So can you see, guys, this is now in the standard form. What we mean by standard form, that's when we have ax squared plus bx plus c is equals to 0. This is the standard equation for a quadratic equation. So the moment you see something that has got power, it means you just want to simplify or work it out until it's in this standard form. So there you go. That means now you can factorize. So you only factorize if this is equated to 0. If it was equated to 9 or whatever number, you transpose and equate it to 0, then rewrite it in the standard form before you factorize. So it seems like this is easy to factorize. Let's see, I think we have 7 and 3, of which when you multiply this by that, it gives you 21. Remember, the bigger number takes the sign of the middle term. Middle term is negative, then 7 becomes -7. Therefore, it means this will have to be positive. Why? Because for you to get -21, that's if you multiply a positive number by a negative number. Therefore, it seems like your y is equals to -3, or
Sir,
y is equals to 7.
sir, isn't it important to put the bigger number on the first bracket?
Someone is saying something. Can you come again, Madam Speaker? What did you say?
I'm saying, isn't it important to take the bigger number to the first bracket?
Oh, you are asking if shouldn't we take the bigger number to the first bracket?
Yes.
If that's what you said, Madam Speaker, it doesn't matter whether you write this on the first side or this on the left side. So it's more like this thing, if that is, let's say, b, obviously multiplied by n. If this is a f, it's more like you are asking if f times b is the same thing as b times f. It is the same thing. So it doesn't matter whether you start with this having a smaller number or this having a bigger number. I'm going to tell you something of which it will make sense. Between a positive 3 and negative 3, which number is big?
-3.
+3.
So 3.
Positive.
So Anita, can you see? In your mind, you are thinking because 7 it's a bigger number to 3. That's not how you interpret. This is not 7, guys. This is -7, and this is positive y. This is positive 3, and this is positive y.
Sir,
Very, very much important, ladies and gentlemen. Someone wanted to ask a question. Go for it.
wait, sir, wait. I'm kind of confused. Wait, how did you get the minus y squared? Did you divide it by -2, or I'm confused?
Wait, -2.
Negative y squared.
Wait, guys. I'm not sure what's going on over there. Let me just quickly confirm something. 7 times 3 is 21 years. 7 minus 3 is 4. Okay, LB, what are you saying?
Say, okay, it's negative y squared plus 4y plus 21 is equals to 0. I'm asking you, how did you get the negative y squared?
Negative was, oh, okay, no, you are the, okay, no, I see. So what LB is asking about, guys, is this part. It's actually this part. Where did I get negative y squared? So remember, this is one namuni. No, this is one orange minus 2 oranges. What are you getting when you punch on a calculator? So when you punch 1 minus 2, what are you getting? You get -1 orange. So that's where I got that negative y squared. I'm not sure if you are answered, Madam Speaker. Are you answered?
Yes, sir.
Okay, 100%. So, good people, can you see now that we have the y values? So, you need to take this y values into equation number 3 in order to calculate the x value. So, that means we have x, which is equals to 2 into the first y, let's punch -3 and say -4. What is that, guys? And again, you do the same calculation, but where you substitute 7 there. So what are you getting there, guys?
-10. -10.
-10. And then there, what are you guys getting? That times that is 14 minus that. Is it not 10?
10.
I think it's
10,
positive 10. Yes. So that means this is how you score yourself a full 6 marks. Let me just quickly show you. Sometimes to mathematically represent this, you can say where x is -10, the corresponding y value is -3. Or where x is what? 10. The corresponding y value is 7. So this is how you can represent your answers in a form of a coordinate. So guys, what I like about solve for x is that you can prove if your answer is wrong or correct. So I'll just remove this portion because I hope you fully understood that part. So I never got a less than 80% with solve for x. In most cases, I'll get total because I'm able to prove if my final answer is correct. So let me just show you something over there. If you are given an equation and they say 2x minus 4 is equals to let's say 2. So what is this, guys? This is an equation. Why am I saying it's an equation? Is because I see an equal sign there. So because it's an equation, what am I supposed to do? I have to solve. What am I solving? I'm solving for the unknown. What is the unknown? The unknown is represented by letter. What letter is used in this case to represent the unknown is letter X. What does it mean? It means finally you must say X is equals to whatever number. So because already I notice I've got an equation over there. What type of an equation is this? Is it a linear equation or is it a quadratic equation? It's a linear equation. Why? Because
Linear.
exponent is 1 over there. So what does it mean? It means you want to have letter on the left and numbers on the right. So this is the summary for a linear equation. So you transpose, then you have 2x is equals to 2 plus 4. Then you have 2x which is equals to, what is that? This is 6. Then you divide by 2 so that it cancels. You remain with x. Whatever that you do on the left, you do on the right. So 6 divided by 2, it's equals to what? It's equals to 3. So what does it mean? It means the unknown is equals to 3. So what do I mean when I say in mathematics you can prove if your final answer is wrong or correct? Is because wherever I see 2, I see x, I can substitute 3. So when I substitute 3 there and minus 4, I must get 2. If I don't get 2, then it means my final answer is wrong. So guys, are we getting 2 when we punch that thing over there?
Sir.
Sir.
Yes.
So that means x, it is indeed equal to 3. So let's prove with our simultaneous equation. So I used to make sure that I prove because with simultaneous equation it's allocated 2 marks. So what does it mean, guys? We firstly prove using the first coordinates, then we firstly prove using the second values. So that means on the first equation you only use this equation and that equation. These are the original equations, not that one because you derived this one from that equation. So that means wherever we see x, if we substitute negative 10, the corresponding value we substitute negative 3. So that means when you punch on a calculator negative 10 and then you plus by that 4, it must give you the same answer as when you say 2, what is it? Negative 3. If this and this are the same, then it means this part of your answer it's possibly correct. So let's see and test with that that other one. So that means if you test with this one, you are going to substitute, let's say positive 10, you plus with 4, then this must be equals to 2 into 10. You must also get the same thing. If you don't, then it means wait, not 10, guys. Can you see?
It's
7.
7.
100%. So as I'm writing, just make sure that you punch so that we are going to check if we're getting the same answers. So can you see? This is for the first equation. This is how you test for the first equation. Let's test for the second equation. So that means what is y? Y is negative 3. When you punch negative 3 squared minus x is what? X is negative 10. And then y it's negative 3 and you plus 21, this must be equals to 0. If you don't get 0, then it means something is wrong with your answers. Let's also test with that one. So wherever you see y, you are substituting 7. Then it's minus into here, x is positive 10, y it's 7. When you plus 21, it must give you 0. So guys, did you try to punch and get the correct answers for equation number 1 and equation number 2?
Yes,
Yes.
sir.
Okay.
So you guys are saying when we test all of those, we get what we're expecting.
Sir.
Okay, 100%. So guys, this is how you solve for a simultaneous equation. So anyone to choose for the next one, remember, just mention your name. I'll recognize you, then afterwards you will tell us the province.
Determination, sir. Maybe we should do 1.4.
1.4. Okay, who chose for 1.4?
Determination.
Determination. Okay, so determination, let me see. Okay, but it's fine. I wanted to say let's also put it in the end. But LB, let me take this one, then you'll take that other one. So determination, let's give it a try and see. Because these last questions, that's where they want you to apply some knowledge there. But it's fine. Let's see. It says determine the value of values. So guys, every time when something is written like this, a value of values, it's more like examiner wants to say you might find two values or maybe just one value. So just be careful of this type of question. So they don't want to say determine the values, because the moment they write it as values, it means you have more than one answer. But when they write it like this, it's more like you can possibly get one or two values. But you know that if they add that s, it's just a style of saying give both of them. So they just want to say specifically two values of whatever. So the question says determine the value or values of p if g of x, if g of x is equals to negative 2 x squared plus p x plus 3. Determine the value or values of p if g of x is equals to that has a maximum value of that. So if it has a maximum value which is equal to 3 as a whole number, then 1/8. So remember guys, before I even start with this problem, just know that g of x, that means we are talking about a function. What we know that a function is drawn on a Cartesian plane which has got the y and the x-axis. So that means for you to be able to answer that question, you must have a background of the functions. So what type of a function is it? Is it a straight line? Is it a parabola, hyperbola, or exponential? It's a parabola. Why? Because we see that x squared over there. So because it's a parabola, here comes the question. Does it have a smiling or a sad shape? Remember, we said this is the general equation of a parabola, ax squared plus bx plus c. And we said that it determines if the graph is going to look like that or like that. So if this a value is positive, then we have a smiling shape. If this a value is negative, then we have a sad shape. Someone is asking, what do I mean by a shape? So a smiling shape, you can see, is that type of a shape, but a said shape is this type of a shape. So for this, what type of a shape are we going to have?
A set faces.
We are going to have a said shape. Why? Because our A value is negative. So this is all that I wanted to explain. And most importantly, can you see that value is a positive value? That is why my graph cuts the y-axis on the positive side of the y-axis. When I do functions, guys, please make sure to not miss that lesson, because I'm going to teach you how to estimate how the graph looks like without you having to calculate or find the values in terms of, for example, this parabola, it was actually making a U-turn at the origin. But now, because of that B value, it shifts it either to the left or to the right. And again, because of that, it shifts it upwards or downwards. So because it's a positive value, then it's upwards. That's why it creates a set shape, and again, it cuts the y-axis at that point, which is 0.3. So, guys, maximum value. You know very well that it's either you have maximum or minimum. So that means you have two values, maximum or minimum value. So every time when we talk about maximum, we are talking about the set shape. So every time when we talk about the minimum, we are talking about, for example, I'll just draw it like that and say we talk about a smiling shape. So the maximum point that we are talking about, guys, where is that point? So the maximum, we are talking about that highest point over there, and the minimum, we are talking about the lowest point. So in terms of the max and the minimum, we are actually talking about the turning points. It's as easy as that. So that means, guys, for maximum value, that's when we have a said shape. For a minimum value, that's when we have a smiling shape. So a termination, I haven't really started answering your question, but what I want to do is just to give an extra lesson, just so that you learn something new out of this problem. So let's now try to interpret what that problem wants us to do. Before I remove all of that, let me try to redraw this so that you fully understand exactly what we are doing over there. So let me draw that and say this is whatever that we are having there. And then this is a 3, but it doesn't matter that much. So we know that this is the graph of a G. So remember, this is the point that we are talking about because it's the maximum. So they are actually saying let's determine the value or values of P if G of X is equals to all of that has a maximum value of that. So can someone just punch that and let me know what it is in a form of a fraction? What is that, guys? Can someone just punch that?
3/8, sir.
What is it? 3
25/8.
over 8. Are you sure? Let me just check. So 3 is a whole number. Remember, 3 is a whole number.
That's 25/8, sir.
Yeah, so 3 is a whole number. So that
Yes,
is
25/8.
25 over 25 over 8. So I want to make you guys aware of something. Remember, are we all on the same page when we say we understand that this point is a maximum point of a parabola having that equation? I hope we are all on the same page on that one. So the first thing that we need to do, determination, we need to determine the y value and the x value of a parabola. That is the first thing that we need to do. So you would also do the same if you were determining the minimum. So remember, at the turning point, the x value at the turning point is equals to negative b over 2a. I'm not sure if you guys know this formula. So that is why I was saying, for you to fully understand, you must have attended my lessons on functions. So if you missed it, is there online. It has been done, it has been posted, but I think it might worth it that when you get a chance, you view those lessons. So this is how you calculate the x value at the turning point. So let me just give you an example. Let's say we had y is equals to, this is that equation. Let's say maybe it was negative 2x squared minus 2x plus 3. I'm just giving an example. If we had to use this equation being an equation of that parabola to determine the x value at the turning point, the x value, we use that formula to say x is equals to negative. What is b there, guys? B, isn't it negative 2? It is negative 2. Then you say 2. What is a? There, a, you can see it's negative 2. Then you punch all of this. I think there you have positive 2 over negative 4. So that means the x value, it's negative 1 over 2. So it actually means for this equation, that function, it is actually making a U-turn. I mean, it is actually on this side of the turning point, is on this side of that y-axis because the x value is negative 1 over 4. Then for you to determine the y value, you take that same x value, you substitute it there and there, then you punch all of this, then it's going to give you the y value. So in this case, or for this problem, we are given the y value already, which is that real number 1 over 8, because it is the maximum. So this is how you now solve for this problem determination. So let's see, guys. Let's see. If we use this formula, x is equals to negative b over 2a to determine the x value at the turning point, using that equation, what is b? What is that b according to that?
It's
Negative.
negative.
So our b is negative p in this case. Then you divide. What is a?
Negative 2.
If 2.
So our a is negative 2. Then you now simplify. So what are we having? We have positive p. That times that is negative 4. So it's more like we have negative p over 4. I'm not sure if that part makes sense to everyone. Does it make sense to everyone up to this point?
Yes, sir.
Yes,
Say it's
sir.
negative 4.
So remember, guys, this thing is the same as negative p over 4. And again, is the same thing as p over negative 4. And again, is the same thing as negative p over 4. Is the same thing as negative p over 4. So don't worry that much in terms of where the negative is positioned. As long as it is there, it's the same thing. So I hope someone is happy with that explanation. Okay, so now that we know the x value at the turning point, we now need to substitute into that equation to solve for the unknown. So let's see. The y value, remember the whole of this equation is the same as y is equals to negative 2x squared minus a px plus 3. So remember, this thing that we calculated is the x value at the turning point. Or maybe let me just try to redraw that as an example so that it makes sense. So this thing that we calculated is actually that x value there at the turning point. So that is what we calculated using this formula. So this formula, it gives you the x value at the turning point. So what about the y value at the turning point? So we are given the y value at the turning point is this one. This is the maximum value that we are given. So that means if we were given the minimum value, it means it is that y, but it's only that we have a smiling shape. So it doesn't matter whether you are given the maximum or the minimum. So I hope that makes sense, guys. So that means you substitute this there as 25 over 8. Doesn't matter whether you substitute it as that. But can you see? Someone said that
Oh,
thing
sir,
is 3
25
over 8.
over 8 is representing our y.
Yes. So that 25 over 8, it's more like it is the y value at the turning point. We calculated the x value, they gave us the y value. I'm not sure if it makes sense, guys.
It makes sense. Even, oh yeah, it makes sense.
Yes. Determination. You are the one who requested. Does it make sense?
Sir.
Okay. So what I wanted to say was that be careful of that thing written as a whole number. So can you see, guys, examiner tries to be tricky in many possible ways. You just need to be aware that if you are given something similar to that, punch it on a calculator. There must be that sign where you can punch maybe 3 there, 1 there, then over whatever. Then get it as a simple fraction as something over something. Very, very much important, guys. So let's now substitute everything. So remember, make sure that your mic is muted, guys, in case if you are not suggesting, let me say, Anita.
I'm getting 3 over 8 instead of that 25 over 8.
Okay, so let's make sure to correct that one before we proceed, guys. Can you see on that fraction
Let her
button on your
let
calculator,
let
you
her
have
press shift
someone is suggesting something there,
Yeah,
Anita, to say
press shift
press
and then the fraction
press
sign.
shift,
yeah.
press
She must
shift,
get 25
then
over 8.
press this button on your calculator. That's
Thank
how you get
you.
to that 100%. So let's now proceed. So that means this is y, then you equate it to the whole of that. But we already know the x value at the turning point is that. So wherever we see x, we substitute that. Let's see. We have minus 2. This is our x, which is negative negative p over 4 squared minus p into, we are only interested in substituting where we see x. Anything else, we write it as it is. So can you see, guys, this is what you end up having. So you have 25 over 8, which is equals to there. This thing, it squares that, and this thing, it also squares that. Very, very much important, guys, that when you get to this stage, you fully understand exactly what you are doing over there. So it's more like you have my minus 2, then that negative, because of that squared, is going to be positive. Therefore, it ends up being p squared over 4 squared. What is 4 squared, guys? Is it 16?
So it's
What is
16.
that? If it's
Yeah,
six,
it's
if
16,
it's
sir.
16, let's write 16. Then minus. Before I even say minus, can you see you have minus times minus? It becomes positive. P times P is P squared over a 4. Then plus 3. So can you see, guys, we are just solving for the unknown here. The most important thing was for you to equate all of that. But going forward, or as we proceed with our calculations, it's just a matter of us simplifying. So let's see, guys. This times that. So
Can I
you have 25. Yes, go
say,
for it. Mhm.
can I ask, where there is negative p, you said it's positive p squared, and then what about the denominator? Ain't you gonna like multiply with p to be 4p?
Eh, okay. Okay, no, I think I understand you. So it's more like you are saying if we have P and you also have P over 4, it's mathematically
Yeah.
wrong to say this P times that and this times that. Um,
Okay.
that's not, yeah. So this thing, in other words, this thing, maybe let me just say P over 4. This thing is the same as 1 over 4P.
Oh,
So
okay.
the other P is only multiplying that P. And P has an invisible 1 there. 1 times that 1 over 4 is that. So it's mathematically wrong to multiply it like that. So I
Okay.
hope it makes sense. So let's see, guys. What are we having? I think it's now getting a little bit tricky now. Okay, it's fine. So let's proceed. So can you see? You multiply that by that. So that means you are going to have negative 2 p squared over 16. What are we having there? We have plus p squared over 4 plus 3. Uh, I'm not sure if we are still on the same page up to that point, guys.
Yes, sir.
Okay, so remember, guys, here comes the question. Is this thing, does it look like, okay, I'll ask this way. Is this obviously it's an equation. Let me structure my question nicely. What type of an equation is this?
Quadratic equation. That's a quadratic
Why are you
equation
saying it's a quadratic equation?
because it's represented
It
by
has a
square.
squared.
Raised to the power 2.
100%. So you have an idea now. So, but there's something interesting there of which I want to make you guys aware of. So can you guys see that we've got like terms there of p squared, p squared? I'm just going to rewrite this thing nicely. I'm not sure if you guys are aware that just this part is actually 2 over 16, which is 1 over 8. I'm not sure if it makes sense to everyone. So it's more like we have 1 over 8 p squared plus 1 over 4 p squared plus that 3. Here we have 25 over 8. Do you guys agree with me on that one? And does it make sense to everyone?
Yes, sir,
Yes.
it makes
100%, which means we can punch this on a calculator because it's negative 1 over 8 of zebras plus 1 over 4 of zebras. So what is negative 1 over 8 of zebras plus 1 over 4 of zebras? Is it not 1 over 8 zebras, guys?
1 over 8.
It is, isn't it? Guys, do
Yes,
you
sir.
agree? 100%. So
Yes, sir, it's 1 over
that
8.
so that means it's 1 over 8. We have just did that plus that 3. We still have that. So we can just transpose that to the other side, which means we are just going to remain with 1 over 8p on one side. Then we have 25 over 8. You transpose, then it's minus 3. So what is this, guys, when you punch it on a calculator? What is that?
It's 1/8. 1/8.
She is getting 1 over 8. So
Yes, it's
now
1 over
what I
8.
want to do is to remove that 1 over 8 there, because remember, I'm solving for the unknown, which is p. So that means I'm going to divide by 1 over 8 deliberately so that it cancels. Whatever that you do on the left, you do on the right. So can you see here, you divide same thing by the same thing, you know it's 1. So what is 1? 1 is equals to p squared. Then for you to solve for p, it means you can introduce a square root on both sides to remove that squared so that you remain with p, which is equals to a square root of 1, guys. Is it not plus or minus 1?
Yes, sir.
It's 1.
It's 1, sir.
So when you say
Positive.
square root, when you say square root, it's plus or minus. So I just want to quickly show you guys something in terms of why are we having plus or minus there. Remember, we have this thing, we have that. What else are we having? So I just made an assumption that maybe this thing is like that. So we already had those values of the turning points. We calculated x, and yes, we calculated x. We were given the y value as that 25 over 8. So the p value has got plus or minus because obviously when you factorize to find the factors, you are going to have two values of x for a parabola. So, but anyway, don't stress that much. I just wanted to bring to your attention that when you say square root of something, this thing is the same as plus or minus that something. So if you have 4 and you end up saying square root of 4, this is the same as a plus or minus 2 as your answer. So determination, this is how you determine an answer to that question. I hope it made sense to everyone. So guys, the next one I'm going to choose for myself and give you 2 minutes to work it out as I find my power bank, because I notice I'm about to run out of battery. Today's Friday, guys. If possible,
Guys,
let's push let's push and push and push. Someone was saying something. Was it a question? What was it? Guys, this one that I'm going to give to you, I'm telling you, no one is going to get it correct. This one, 2x. Guys, work out this one, which is allocated 2 marks. So, in case if you get to the final answer, don't mention it. Don't mention it. Just make sure that you get your answer, and then I'll let you know what to do. So I'm giving you guys less than 2 minutes. I just want to quickly get my power bank, then I'll be back shortly. Guys, is there someone who's done?
Yes,
So
Done, sir.
Seems
Okay,
like
speaking.
it seems like most of you guys are done, but I'm not hearing any gent saying they are done. But it's fine. Let's see. How well? What are you getting there? Anita, what are you getting? Lerato, what are you getting? Who else said they got it? LB, did you
Same.
say something?
I got 0
Anita, sir.
for both.
Anita.
0 and positive 0 and positive 3.
Eh?
0 and
What?
3.
I had someone
0
mentioning
and
the
3.
word impossible. Now I'm
Okay,
getting
Anita
one.
speaking. Say I got -2 and +3.
-2 and +3.
So I'm getting
See, I got
positive
positive 3
and
and
positive
a 0.
Kauchel is speaking. I also said God 0 and positive 3.
Okay.
Just speaking, say I got +3 and -2.
+3, -2, +3, -2. Okay, it's fine. Let's work it out together. I wonder if we still have chance in this group, because I'm not able to see. I think I'll just have to stand up and see who has attended. But it's fine. Ladies and gentlemen, remember, guys. What this is an no. What is this, guys?
Linear equation.
The equation.
What type of an equation is this, and why are you saying this is an equation?
Because it's equals to 0.
because the left hand side is equated to
Now I say it's a quadratic when you remove the brackets.
Okay, so let me just quickly explain it to everyone. Listen very carefully, guys. This is a mathematical problem that we know. So, what is this? This is an equation. Why am I saying it's an equation? It's because I see an equal sign over there. That means I must solve. What am I solving? I must solve for the unknown. What is the unknown? The unknown is represented by a letter, which could be any letter from A up to Z. But in this case, Mr. Examiner used letter X. So that means in the end, I must say X is equals to something. So what type of an equation is this? It's either it's a linear equation or it's a quadratic equation. If it's a linear equation, I'm just going to have one value of X. If it's a quadratic equation, I'm going to have two values of the unknown, which is represented by letter X. So at this stage, I might not be able to tell if it's a linear or a quadratic. But the moment I remove the brackets, that's when I'll be able to tell what type of an equation is this. So if you say that by that, that by that, then you have 2x squared minus 6x, which is equated to 0. Then, because of this, I'm aware this is a quadratic equation. So always, when you notice you have a quadratic equation, you want to have everything moved to the left side and have everything equated to 0. So already this is equated to 0, which means you did not have to multiply that by that, that by that. Why not? Because this thing is already factorized. So it's more like it's already given to you as 2x plus 0, and again x minus 3 is equals to 0. So the whole of this thing is actually just that. The whole of this thing is actually that. So it's equated to 0. And by the look of things, guys, we don't need to sweat. So that means the first monomial you equate it to 0, that monomial you equate it to 0. So that means you actually have a 2x being equals to 0, or x minus 3 equals to 0. So remember, guys, you want to remove that 2. How do you remove that 2? You deliberately divide by 2 so that it cancels. Whatever that you do on the left, you do on the right. So what is 0 divided by 2? I think it's 0, guys. If you punch it on a calculator, it must give you 0. Then on the other side, you transpose. Therefore, x is equals to positive 3, which means you have two values of x. Why are you having two values of x? Is because this is a quadratic equation. Good people, are you all happy?
No. Sir, can I prove
Yes,
my
sir.
answer, please?
Yes. No, it's fine. Go for it.
Okay, sir. Can you'll be writing by the time I'm talking, or what? What will we be doing?
Wait, I'm being confused. I think is it not Anita who's speaking? Anita, you are recognized, Madam Speaker. Take a chair and make your point.
No, I don't prove. Sir,
Guys,
are you there?
if you are not speaking, make sure you see Didintle Mochampi. Mute your mic before I mute it from my side, because you won't be able to communicate if I mute it from my side. Okay, let
Is
me
it me or I
mute.
can hear the
Okay,
echoes?
sir.
Anita, I'm still here. Go for it.
Okay, this is how I did my thing, ne?
Mm-hmm.
Yeah, I times that 2x with the number that are in the brackets, 2x times x, 2x times minus 3, right? Then I got 2x squared minus 6x is equal to 0. Then I opened two brackets. On those brackets, I put there x plus 2, and then on the other one, I said 2x minus 3.
Wait, the first bracket.
Are we still fine, sir?
Yes, I'm still with you. I was just listening. So the first bracket you're having what? What are you having?
I'm having x plus 2, x plus 2.
Mm-hmm.
X plus 2 and x 2. Okay. And 2x minus 3 was like when
2x
I'm multiplying.
minus 3. So this is what you are having, ne?
Sir?
Because I had you multiplying. I think they then had 6x. Okay, before you continue, Anita, it is
Yes, sir.
mathematically wrong to end up having something similar to these. And the reason for that is because when you multiply this by that, this by that, this by that, this by that, it will never take you back to this, and it will never take you back to this. I'm not sure if you are aware of that, but let's do this together so that you notice you are wrong. When you multiply that by that, you have 2x squared. You agree, isn't it? That by that, you have minus 6x. Do you agree with me on this one, Anita? So how do you factorize
Ish.
this thing? You obviously take factors which are common in these two terms. So 2, it's common there. Also 2 is common there. You take it out. X is common. It's also common there. You take it out. Then inside the brackets, if you took out 2 and x there, you remain with x. If you took out 2 there, it ends up being 3 because you took out 2 and also x, then it's equals to 0. So it took you back to that. So that means you know when you're dealing with a quadratic equation, after factorizing, you just equate this to 0 and that to 0. So that is why you end up having that is equals to that is equals to that, this is equals to positive 3, you divide, that cancels, then you have 0. So guys, I hope that makes perfect sense to
Sir,
everyone. It was just a very quick question. Um, yes, someone is speaking. Is
wait,
it a
it's I'll
question?
be speaking, sir.
Mm-hmm.
I just wanted to say something in case people are confused on how we substituted this for the quadratic equation. In case you don't
Mm-hmm.
have the letter C, you can always use 0 for it, in case people are confused.
Okay, let me just quickly try to rewrite that. So, are you saying we can just say 2x minus 6x plus 0 is equals to 0? Is this what you're
Yes,
saying, LB?
yes. If you don't have the C.
So, I suppose that's in case if someone is using a quadratic formula to determine the factors. So,
Yes, so that's what I'm
uh,
saying.
but you also need to be careful on this one in terms of where the marks are allocated. So just make sure that, because I know LB, on the side of LB, you are right. LB is just saying you will finally, if you use this and you use the quadratic formula, you'll finally get x being that, or x being equals to positive 3. But remember to also show that step where you equate this to 0 and you say this, you equate it to 0. So you might find that both of these it's allocated a mark and both of your answers are allocated a mark. So if you only show your final answer, you might only score a mark. I'm just saying on this one, I'm not yet sure in terms of how the marks are allocated for that one. So guys, someone to also choose a problem of which they feel like it's a little bit confusing. Guys, are you still there?
Yes, sir.
Yeah, yes,
Lebohang,
and yeah.
Lebohang, do you want to choose any problem there?
1.1.3.
1 point?
0.3.
I'm not getting that, guys. She wants 1 point. Which one?
1.1.
1.1.3.
1.1.3.
Oh, 1.1.3.
Yeah.
Okay, so let's see. 1.1.3, we have x minus 1. We also have a, what is it? It's 4 minus a
Can I
x
do it?
plus
Can I do it?
3. Someone is saying something. Are you not able to see there? And this one is allocated. How many marks is it allocated? It's allocated 4 marks. Is there someone who wants to give it a
Can
try
I
or a
do it?
suggestion in terms of how they would approach this one?
Yes,
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 sir.
it's calculus speaking.
How well? Yes, give it a try. You can just share with us in terms of how you would approach this type of a problem.
Okay. Okay, then you firstly remove the brackets, meaning the first bracket will multiply with the second bracket. Then it will give you 4x minus x squared minus give you 4x minus x squared minus 4 plus x is greater or less is. Then if I firstly did the like terms, which is negative x squared plus 4x
Or maybe let's just work it out
plus
with that one
4x.
and say that, because this is where you are heading. Name.
Yeah. Yes,
Mm-hmm.
sir. And
Mm-hmm.
then I'm gonna divide since I don't want like my first x
Your
squared to
A
be
value,
negative, I want it to
it's
be
negative.
positive. So I'm gonna divide all sides with negative 1.
Mm-hmm. Then what happens there?
Three is I used a quadratic formula to get my coordinate to get my uh difference in the brackets.
So did you notice that one?
Yes, I did.
Okay. So remember, when you say you divide or you change the sign, this is also a sign. So you must also change it because you are changing the sign of everything. So it now has
Yes,
to
sir.
change to its opposite sign to be less than or is equals to. So
Less
every time
than.
when you divide by negative a, just for someone else, you also change the inequality sign. Hawelo, asqhubeke.
Yeah, yes. Then say when plus 3, it has to be 5, not 3.
Let me see. How is it 5?
It's because I said it's negative x squared plus 4x plus x. So for where there is a negative, so you see 4x squared minus x squared minus 4, it's plus
Okay.
x, not negative x.
Okay. I think because as you're speaking your line, it's a bit it's breaking a bit. So let me remove all of this and try to explain whatever that you were saying. You are on the right track. So I'm just going to explain, just in case there's someone somewhere in Limpopo, they are listening, but they are also experiencing the potholes. So this is what Howell is saying, guys. She's saying she's going to multiply that or break down that because the arrangement inside the brackets, it's a bit tricky. It's different from when you had x minus 1, x maybe minus 4. But in this case, we have 4 minus x. So she's saying that times that, it gives her a 4x. This times that is 4x. This times that, it's negative x squared. This times that is minus 4. I agree with her. This times that is going to give us a positive value, being positive 4. Let me write it as positive 4 there. Then it's positive 4. It's greater or is equals to 0. So let's work out not positive 4, but positive x. Positive x. Then let's see. She works out the like terms. She has that, she has that. But firstly, she wants to rewrite it in the standard form by starting with that one with x squared. Then this by that, it actually becomes positive 5x. Then this is just a number alone, then is minus 4. greater or is equals to 0. Then we always want to have a positive a value. If it's negative, you change the sign of everything there. So you have x squared, you change it to minus. There is positive, you change it to it's minus, you change it to a positive. This sign also, it changes, it now becomes that. This is positive 0, it's negative 0, is the same as 0. Then from there, let's try to see if we factorize this thing, how is it going to look like? Let's see. If we factorize it, we end up having x, then there we have negative
It's
4.
4 and 1.
We also have that. So you must be able to factorize, guys, or to find factors. LB said when you have a quadratic equation similar to that, you can use a quadratic formula to find the factors. And remember, guys, because of this sign, this thing is called a quadratic inequality. So in this case, it's not an equation. Why? Because this thing, it's not an equation, it's an inequality. So it therefore makes that a quadratic inequality. So that means we have a quadratic inequality, we also have a linear inequality. So the signs for inequalities is less than or is equals to, is less than, is greater than or is equals to, is greater than. These are the signs that we have. You will see how we represent each of these on a number line. So we now get the critical values. So the critical values is more like you say this is equals to 0 and this is equals to 0. It's only when you find the critical values when you can say this is equals to 0. This is equals to 0. So this minus that is equals to 0, or x minus 4 is equals to 0. Then x is equals to positive 1, x is equals to positive 4. So this and these are your critical values, which you represent on a number line. So on your number line, what are you having? You have a smaller value. You start with a smaller value being positive 1. Then here you've got a positive value being 4. So what I've noticed is that in most cases, when you have a sign which is less than, or maybe if it's less than or is equals to, your final answer ends up being a x between 1 and 4. But the sign there is less than or is equal to, is less than or is equal. So you are most likely to have a final answer being that, or in that format. And most importantly, to represent on your number line, if it's less than and it has an equal to there, you draw a circle, then you shade it. A circle, then you shade it. So if it was just less than, you just draw a circle. So it's more like when you represent on a number line, if it's less than or is equal to, it's a circle that you shade. If it's just less than, it's just a circle. If it's greater than or is equal to, you circle and then you shade. If it's just greater than, it's just a circle. So in this case, they were actually asking to say for which values of x, when you substitute there, you are going to get values which are negative, or values which are less than 0. We know that values which are less than 0 are actually negative values. Values which are greater than 0 are actually positive values. So when you punch, let's say, values which are on this side of 4, I'm sure you are going to get positive values. And when you punch values which are on this side of 1, you are going to get positive values. But when you punch values which are between 1 and 2, you are going to get negative values. So that's what they mean when they say for which values of x are you going to have values which are less than or is equals to 0. then you can just join those two dots with a line. So guys, this chapter of inequality, it's something big on its own, of which if you did not attend my previous lessons, you won't even have an idea of what I'm talking about. But worry not. In case if you are my registered learner, I will include this chapter when I'll be doing my winter schools. So remember guys, during winter schools, in this group, I'll only be doing grade 10 stuff. So for grade 11 and 12, I'm going to move everyone in the group for winter school. So just make sure that if you are my registered learner, you send me an inbox requesting a link to move to my new group for winter school. So in the meantime, what I'll be doing is just to send some material in there, some study material, some notes and everything, just so that you can even use them to prepare for your June exam. So I'll be sending some textbooks, some notes and everything that will form part of my lessons for winter classes. So it will only be for grade 11 and 12. So if you're in grade 10, don't worry that much. You'll benefit from that next year. But anyway, however, is this what you wanted to do?
It was Gaugelo, say not Gaugelo.
Oh, Gaugelo. Gaugelo, is this exactly what you were trying to do? I suppose this is what she would have done. So, guys, I'm not sure. Is there someone who's got a question there just to understand something? But one thing for sure, if you did not attend my previous lessons on inequalities, and again, if you haven't done it in class, don't worry that much for now in case if you don't understand. I'm going to study it from the beginning because for now, you might not even understand a thing, but you just need to be aware of how to solve for the unknown, how to factorize, how to get the critical values. Then this part, it's not that much complicated. I'll teach it on a special lesson. But anyway, did you guys understand, or is there someone who's got a question before we move to the other problem?
Yes, sir. I understood, sir.
Yes,
Okay.
understood.
Shreyas, he
That's
got it. He got it. Who else? Gaugelo. She also
yes, sir. I also understand.
LB understand. Oh, is there someone in here who's in Pretoria? Gaugelo, where are you in this world? Who's in this group
I mean,
and stay? Who? Who's in Gauteng?
So it's me.
Gaugelo. I wonder if Gaugelo knows that in Pretoria we call it Kawelo. So don't be surprised next time when I say Kawelo. So that's how we speak in Pretoria. So guys, anyone else who wants to try the other, choose the other. Let me see what other questions are we having there. Let me see. Remember, guys, it's not only question one that we are doing. Um,
Two, sir, please let's do 2.2.3. Question 2.
2, but there's no 2.3 there.
2.2.3.
Sir.
2.2.3.
Yes.
Okay. So let's try 2.2.3. I think this one is also an interesting question of which let's see. So 2.2.3. There, what are we having, guys? We have 2 minus 16x to the exponent negative 3 over 2, which is equals to 0. And this problem is allocated 3 marks. It's allocated 3 marks. Okay, it's fine. So let's see. So when you are given a problem similar to this one, guys, if you notice that on the left side of the equal sign, you have only 2 terms, which is term 1, you have term 2 there, and again on the right side, you just have whatever that it is there. The moment you realize you cannot take out common factor between these 2 terms, if this is a number, take it to the other side and remain with that other term, because you couldn't take out a common factor between these 2. So that means when you transpose, you are going to have 0 minus 2, which is the same as minus 2. The first thing that you can do is to try and remove that negative 16. So it's more like we've got let's say we've got whatever, then we have a diamond. We have a diamond there. So we try to remove everything. We try to remove everything in all possible ways until we just remain with diamond, which is going to be equals to whatever. So can you see that my first step, I've tried to remove some water. So this is water which was surrounding a stone. So I took some water. It's now dry. So now that is dry, let me remove the dust. So this is how you mathematically remove the dust. Remember, whatever you do on the left, you do also on the right. So can you see, I've removed the dust, ladies and gentlemen. So what is this thing? That cancels that. I think this is 1 over 8. Someone will just correct me if it's wrong.
Yes,
So
it's 1 over
can
8.
you see, guys? We did remove the dust, but we still have some smaller nyana stones there. How can we possibly remove the stones? Let me see. If, guys, we have an exponent that you need to remove, firstly, you just multiply by exactly the same thing, but you do the inverse, or maybe you swap the denominator with the numerator. So when I say exactly the same thing, I mean the sign must be the same. If it was a plus there, it was also going to be a plus there, but you swap those two. So that means at the top you're going to have 2 over, at the bottom you're going to have 3. Why did I have to multiply by exactly these things? Because I know that is going to cancel with that. This is going to cancel with that. This is going to cancel with that. There is my diamond. LB, can you tell us, whatever that we do on the left, what do we do with that whatever? Can you just complete that? Let me see. Lerato is
Give
also
it
on
to the
that one.
right as well.
So whatever you do on the left, you do on the right, which means on the right, I'm going to say that 1 over 8, I'm also going to multiply it by negative 2 over 3. So you multiply by exactly that you multiplied with on this side of the equation. So what is this thing, guys? When you punch all of that, what is it?
Positive
False.
4.
Are you guys saying positive 4? Is that what you get?
Yes.
Yes, sir.
Okay, if that is the case, then can we try to prove if this thing is correct, guys? Let's try to prove. So for us to know that is correct, we must substitute this wherever we see x on the original equation. So let's check if that diamond is indeed a legit diamond. So you are going to have that to the exponent 3/2. So can someone tell if that answer is correct?
Yes, sir.
Yeah, it's correct.
How do you know it's correct?
Because when we substitute it, we
Because
are
I
taking
sub
it out. Yeah.
100%, because when you substitute there and you punch all of these, you expect to get the same answer there, which is 0. So can someone choose maybe, let's say, the last one, and then from there, or otherwise, before someone even choose the last one, whatever, let me just randomly select and quickly um solve some of these problems. So let me just remove all of these. I'll just show you how I would solve the rest of this question. Let's say they're saying I'm left with whatever smaller nyana time. Then I know these problems are not that difficult, but I'm running out of time. This is what I'm going to quickly do. So this one is question 2.2.1. Okay, so let me see. So in this case, I've got the unknown as an exponent in this case. So when you have the unknown as an exponent, then try to rewrite this in a different form. So I don't want to be having that fraction there. So I think 1/2 is the same as 2 to the exponent -1. This is equals to 32. So I'm just going to multiply that by that. Then I've got 2 to the exponent negative x, which is equals to what is it? Which is equals to 32. Why is it like this one? Wants to be a little bit tricky, but it's fine. So what I understand with this one is that this thing is actually the same as 1 to the exponent 2 to the exponent x, which is equals to 32. Then I can cross multiply. I know this is over 1. Remember, guys, I'm just talking to myself here. I'm in exam. So you just need to make sure that whatever that I'm doing there, try to check if you can learn something new and try to make sense out of what I'm doing there, so that when I open for questions, you know exactly what you want to know about. So I cross multiply, then it's more like I have a 2 to the exponent x multiplied by 32, which is equals to 1. Then I can remove that 32, then it cancels. Then I remain with 2 to the exponent x, which is equals to 1/32. So again, 1/32 is the same as a 32 to the exponent -1. I hope I'm right with that one. 32 to the exponent -1 over that. So that means I must have the same base on the other side. So that means 2 to the exponent x is possibly equals to 2 to the exponent negative something. So let me check. I'm going to test with maybe 2. 2 to the exponent -2, it's 1/4. Then it doesn't work. 3, it's 1/8. 2 to the exponent -4, it's 1/16. 2 to the exponent -5, it's yes. So that means 2 to the exponent negative 5 is the one which is equals to 32 to the exponent that, or otherwise 1 over 32. That
Sir.
means x is equals to negative 5. Remember, guys, in exam, we don't talk with each other. Otherwise, you will be expelled from examination. So now that I got my x value being equals to negative 5, let me try to quickly prove if my answer is correct. So that means wherever I see a x, I'm going to substitute my value being negative 5. So let me quickly punch and see if that is correct. To the exponent, let me see, negative 5. This is 32. Then it means it's correct. So this is equals to 32. So guys, I was in exam speaking to myself. So now I'm opening for questions. Anyone who's got a question with what I was doing over there? I think someone was speaking. I'm just not sure if it was a question or what, but is there someone who's got a question, guys?
No, sir.
No question from Shreyas. Who was speaking? Ferdinand.
Sir, it was me.
Yes. Was it a question or are you now sorted? Ferdinand, you wanted to ask a question or are you happy there?
No, sir, from my side, Naki sharp.
Okay, 100%. LB, what were you saying before I try the next question? Moleboheng, or writing a lap. Are you there? Are you in today's lesson? Is Moleboheng there?
Yes, sir. I'm okay.
Okay, 100%. So let me quickly try this one, which is that 2, 4, 3. So remember, guys, the moment you have square root of a, this is the same as there's an invisible 2 over there. Unless if maybe you have 3 square root of, let's say, y, then you therefore have 3 over there. So if it's just a square root, this thing is actually the same as a, you have invisible 1 there. So this thing is the same as 1 over 2. So there is an invisible 2 there. So if it's given like this, then it means it's y, then there's invisible 1 there, then you write it as 1 over 3. So maybe if you have, let's say, 4 square root of p to the power 7. So that means in this case you are going to have p, then you have 7. It's no longer invisible 1. You write it at the top, then you say over, then you write 4 at the bottom. So this is a rule that you must know and understand. So let's apply it here. So there we have x, there we have invisible 1. So that means we have 9 in invisible 1. You write that x at the bottom. You can say this is equals to the whole of that. So let's see. So can I try to rewrite this thing as the lowest base? Let me see. I think this thing, what is 9, guys? Is it 3 squared? I think it's 3 squared. I think 9 is 3 squared. If 3 is that, then what is this one? Because already my base is 3, it also has to be 3 to the exponent something. Let me test it. Let's say 3 to the exponent. Maybe let me start with 6. 6 is
Please
too much.
3 to the power 5 6.
Wait. Kawelo. In exam, we don't speak with each other. Let me see. What was I doing, guys? Okay. So I wanted to know what is 3 to the exponent that. So the reason why I'm doing this, however, is it's just so that in case if you are in exam and you get to that stage where you don't even know where to start or how to solve these things, I'm just showing you in terms of how relaxed you should be so that you don't make some mistakes. So I'm just speaking to myself by trying to provide additional information. So already someone knows what is 2, 4, 3. They know it's 3 to the exponent something. But for someone who doesn't know, with what I'm saying, they are now aware that for you to determine this thing, you must have a base. And to decide which base, you are guided by this base on this side already being 3. Then it means you make it 3, then you test. Let's check with 5. Yes. So that means 3 to the exponent 5 is equals to that. So this thing, it multiplies that. So it's exponent multiplying exponent. So remember, who is it? Anita. It can't be 2 over that. It can't be 2 multiplying that and 2 multiplying that. I'm sure you are now confident with that one, or you fully understand it now, which means this thing is actually the same as 3 to the exponent 2 over x, which is equals to 3 to the exponent 5. So now can you see I've got the same basis. They can just fall away and I equate the exponent. So this is an exponent which is in a fraction form. So this fall away, then I remain with 2 over x, which is equals to 5. I know if it's a fraction there, I can also say over 1 so that I cross multiply. Then I have 5 over that being equals to 2. Then I divide by 5 deliberately so that it cancels. Then my x is equals to, what is it? Is it 2 over 5? Okay, let me check if what I've done over there is correct. So that means I must punch 2 over 5 square root of 9 and expect to get that as an answer. Let's see. Where is that thing is on my calculator? Or the shift, which is x to that, then open bracket, a fraction button, 3, 2 over that. Then I go to the bracket, I punch 9. Hey, I'm getting, no. I made a mistake because I said 2 over 3. It is supposed to be 2 over 5. Let me see. Yes. Avumile. Matlos. So, guys, anyone who's got a question, you can now talk to me. Talk to me, guys. Any step that you need clarity on?
No questions, sir.
No questions.
Okay. Since no question, I'm doing this last one. Then LB, you are going to be given an opportunity to close with that other question. So in this case, let's say you are given 2 to the exponent x minus 5 times 2 to the exponent x plus 1. This is equals to negative 144. Check how many terms do you have there. You have 1, 2 terms. You have 1 term there. So in these 2 terms, can you take out something as common factor? let's say it's not clear,
20,000.
then let's expand that. So that means you have 2 to the exponent x minus 5 times 2 to the exponent x times 2. You have invisible 1 over there, negative 144. So remember, guys, you need to be able to be aware of those exponential laws to expand that. So can you see we now have a common factor of which we can take it out as 2 to the exponent x into, then you remain with 1 over there, minus, you remain with this multiplying by that. What is that times that? I think it's 10. It has to be 10. This is negative 144. So you just simplify this minus that, it's negative 9. It's equals to that. Then you want to remove everything so that you get closer to your diamond. Let's see, that cancels. Then what is this one? So we have 2 to the exponent that, negative 144 divided by negative 9. I'm getting 16. Then it means 2 to the exponent that, it has to be 2 because the basis must be the same to the exponent something, and I know that 16 is 2 to the exponent 4. The bases are the same, they fall away, you equate the exponents. So that means that is equals to 4. So if you substitute 4 there and there, you must get negative 1, what is it? Negative 144. So any question before LB closes our lesson for today? I removed already, but I don't think it was confusing, guys. Did you guys understand what I did there?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, 100%. So, LB, you can go for that one which says discuss the nature of the roots of this equation. Discuss the nature of the roots of equation. I just want to write it down so that when you explain, everyone can see what is going on over there. So, LB, we all have our mics muted.
So I really can't hear you.
Guys, I was saying LB can. Why is it like LB is gone? Is there someone else
Not
who
here,
wants to give
sir.
it a try? Can you hear me now?
Yes, sir.
Anita,
Can I
do
take over?
you not want to give it a try? Lerato?
Yes, sir. Can I try?
Yes, you can give it a try.
So 7 say 2 times x. We'll have 2x.
Wait. Or maybe you can just explain in terms of how you'd approach this question, so that I have an idea if you are heading to the right direction or not.
Hey, sir, I don't know how to explain it, but sir, please write everything that I'll say it down. Please write it down. Maybe.
Okay, so let me write it down. Okay, let's
So
go.
sir, 2 and open 2 brackets.
Mhm. Okay, let me say this, Lerato. So you want to have this in the standard form, ne? Is that what you want to do?
Oh, yes, sir. First, I'll say 2x minus 6, then I close the brackets and raise all of that to the power 2. Then plus 2
But
equal
but
to...
wait, Lerato. Minus 6, where is the 6 coming from?
Sir, I'll say 2. I'll open a bracket.
Mm-hmm.
Please erase this one, sir. Remove that.
Lerato is breaking. I'm not sure. Okay, it's fine because you're breaking, Lerato. Let me take it from here and try to explain to Shriyas what is going on over there. I'm sure there might be someone who might also so Shriyas, they want you to discuss the nature of the rules of this equation. So the first thing that you need to do, Shriyas, is to have this thing in the standard form. That is your first thing that you want to do. So let's write it in the standard form. Already because of that squared, we understand it's a quadratic equation. So that means you are going to have 2 into x minus 3, you close, then you have 2 of the same thing. Because of that squared, it means you have 2 of this. Then you still have that plus 2, it's equals to 0. Then you say this times that, this times that, this times that, this times that. So you still have that 2 on the outside. This times this, it's x squared. That times that, it's minus 3x. That times that, minus 3x. That times that, you have positive 9, you close, plus 2, it's equals to 0. So can you see 2 of this? You can write it as x squared minus 6x plus 9, you close, plus 2, it's equals to 0. So all I'm doing, guys, is just to rewrite this in the standard form. So therefore, I have this times that, this times that, this times that. So can you see, guys, you don't start by saying 2 by that by that, and then from there you have 2x, maybe minus 6 squared, then you open the brackets. It's mathematically wrong. You start with this, and then you multiply that by that while writing that on the outside. So now you have 2x squared, that times that, it's minus 12x. That by that is positive 18. You have plus 2 is equals to 0. So can you see we can work out that part. So we have 2x squared minus 12x. This is plus 20 is equals to 0. So we have common factor of 2, 2, 2. So we therefore have 2x squared. There we have minus 6. And there we have plus 10. This is equals to, what is it? We can say it's equals to what is it, guys? It's equals to 0. Then from there, you remember that delta. I'm not sure. Is there someone who's in this lesson who can then explain this part for us? Let me give someone
Try
an
it.
opportunity. Hawelo wants to give you a try, and I know Dimpo. She's on the line and she understands it very well. But Shriyas, up to this point, did you understand? And everyone else?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, 100%. The one who's speaking, is it Kawel? Is it Kawelo or is it Khawkhel? The one who wants to give it a try.
It's hello, sir.
Oh, Khawkhel with H. Okay.
Sorry, sir.
Khawelo, take it from there.
Um, as we see, sir. Hey, I don't know
Mm-hmm.
how to explain it, but then I'll give it a try, sir.
Mm-hmm.
Where we see b squared we substitute 6x.
Okay. You are on the right track. So what she's saying is that wherever we see b, we just take it from that standard equation there and substitute into the formula. So b, it's negative 6 then squared minus 4. What is a? A is 1.
X squared.
Then we
Oh,
have
wow.
our c being 10. Then when we punch all of this, what is that?
-4.
Eh?
It's -4.
Negative.
-4.
-4.
Oh, wait, guys. Wait, guys. I just noticed something. So here, we do not divide by that common factor there. So that means we leave it as it is over there. And the reason for that is because it's not like we are going to factorize this thing. We just wanted to write it in the standard form. So it is now in the standard form. So that is equals to b squared minus 4ac. Maybe let me add to say, Shreyas, do not worry that much. As long as you understood up to this stage, it's fine for you and Mr. Ferdinand that side. I don't think you guys get up to this stage. So yours, it will just end up to there. I think it's grade 11s or grade 12s who take it further from there. So even if you guys in grade 10, you understood up to that point and you don't understand this part, do not worry that much. What you needed to do is only this section of the calculation. So let's see. How Hello was saying we substitute. What is our b is -12 squared minus 4. What is our a is 2. What is our c is 20. So this is what we substitute. And what are we getting there?
-16.
So
-16.
we are getting -16. Then in conclusion, what can we say about the roots?
The roots are non-real
Why are you saying the roots are non-real?
because delta is less than 0.
Say that again, Lerato.
Because our delta is less than 0, sir.
So, okay, Lerato is saying if our delta is less than 0, then we have non-real roots. Is that what you're saying, Lerato?
Yes, sir.
What if, these are the type of questions that you should ask yourself. What if delta is greater than 0? Does it mean we just have the opposite there?
No, sir. It could happen that we have real roots, but they are irrational or rational.
So that means if we had a positive value there, are you saying we say real roots, but they could be rational or irrational? Is that what you're saying?
Yes, sir.
So how do we conclude? What if we had positive 16 there?
We would have real rational.
Real, but rational. So what is the difference between rational and irrational? What if we had positive 17 there or positive 13 there?
We usually say the roots are rational when we have fx squared.
So that means if we have a perfect square, then they are rational. If they are not a perfect square, then you say it's irrational. Is that what you're saying, Erat?
Yes, sir.
Okay. What if our delta was equals to 0?
We would have real, rational, and equal roots there.
We will have an equal root, sir.
Real, rational, and equal.
So you guys are saying if delta is equals to 0, then we have equal roots.
Yes, because anything that will be minus together will give you zero. Those are real.
They are real, rational, and equal.
So they are real and equal roots. That's what you guys are saying.
Yes, yes, and also rational.
And also, so real, rational, and also equal.
Yes, sir.
I hope someone somewhere is writing the notes. So, Shreyas, I hope to some an extent you were answered. So, this part that we were discussing now, it shouldn't worry you that much. But anyway, guys, I hope today's lesson it did open your eyes, and I think it was a refreshing lesson. So over the next 2 days, there might not be lessons, because sorry guys, I'll be preparing for a new chapter that we'll be starting with on Monday. So I'll only be doing the private lessons tomorrow. So I think I've had too many bookings such that I won't be able to do a lesson. So this is also an opportunity for you guys to also catch up. So have you guys started with electricity? But just before I make this point, let me just end this lesson because this part doesn't need to be on record. Let me just stop record.